Hi guys, today let us study about two-stroke engines and the principle and working for a two-stroke petrol engine. A two-stroke engine will complete one cycle with only two strokes, namely the upward stroke and the downward stroke. Compared to a four-stroke engine, here there will be no separate suction and exhaust strokes, but these are performed while the compression and power stroke are in progress. Hence, the working cycle will be completed for only one revolution of the crankshaft. In a two-stroke engine, there is three ports. The inlet port, through which the fuel or charge enters the case, the exhaust port, through which the burnt gases are discharged to the atmosphere, and also in addition it will have a transfer port, through which the charge is transferred from the crankcase to the cylinder. Now, let us study the principle and working of a two-stroke petrol engine. Well, this engine will work on the Otto cycle, that is, the combustion of fuel takes place at a constant volume. First, the downward stroke. Now, let us say that the piston is currently at the top dead center. From the figure, we can say that the air and petrol mixture which has entered into the cylinder in the previous cycle is compressed to a high pressure and temperature. In the meantime, the inlet port is also opened. As a result, fresh charge of air and petrol mixture will enter the crankcase. The exhaust port and transfer port are now remain closed. Now, the compressed charge which is present in the cylinder from the previous cycle is ignited by means of the spark generated by a spark plug. The combustion of fuel will take place. This combustion will lead to the expansion of the burnt gases, and this expansion will exert a large force on the piston, causing it to reciprocate rapidly from the TDC to the BDC. This force will then be transmitted to the crankshaft through the connecting rod. As a result, the crankshaft will rotate at high speeds. This is then transmitted to the clutches and gears and other transmission elements, and finally it is used to turn the wheels of the vehicle. Meanwhile, when the piston is being pushed down by the expanding gases, the exhaust port will be uncovered. Hence, a part of the burnt gases due to their own expansion will escape through this exhaust port. As the cycle continues, the further downward movement of the piston will lead to the opening of the transfer port. Here, we can also note that the further downward movement of the piston will compress the air-petrol mixture that is present in the crankcase. Thus, this pressure exerted will cause the charge from the crankcase to rush into the cylinder head through the transfer port. Meanwhile, the fresh charge entering the cylinder will drive away the remaining burnt gases through the exhaust port. In this manner, the exhaustion of the burnt gases will take place while the power stroke is still in progress. When the piston will reach the BDC, this downward stroke is completed. Hence, the crankshaft will complete half of a revolution. Now, the upward stroke. During this stroke, the piston will now move from BDC to TDC. As this happens, it covers the transfer port, thereby stopping the flow of fresh charge from the crankcase into the cylinder. Further upward movement of the piston will also cover the exhaust port. Now, the inlet port will open and the upward moving piston will create a partial vacuum in the crankcase. Hence, fresh charge of fuel and air mixture is drawn inside the crankcase through the inlet port. Thus, we can see that the intake of the fresh charge takes place while the compression stroke is still in progress. When the piston finally reaches the top dead center, the upward stroke is completed. In this stroke, the crankshaft completes one more half revolution, and hence it will complete a total of one revolution in the cycle. This process is continued again and again for the production of continuous power. Well, the two-stroke petrol engines are used for light-duty vehicles such as mopeds, scooters and motorcycles. Thank you.
Wow, that's That's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.